Okay, our second review topic is going to be on the Pythagorean theorem. So as you'll recall, when we were talking about the Pythagorean theorem in geometry, we had a right triangle with legs A and B, and hypotenuse C. And the relationship between the legs and the hypotenuse was a squared plus b squared equals c squared. So if we look at a few examples around our triangle, find x. For our first triangle, we'll have legs of x being the small side, 12 being the larger side, and a hypotenuse of 13. So as you recall, x squared plus 12 squared equals 13 squared, or x squared plus 144 equals 13 squared being 169. We have to subtract the 144 from both sides. We're left with x squared equals 25, and we know that the square root of 25 is 5. For our second triangle, sides 8 and 15, hypotenuse of x, you're going to plug it in. 8 squared plus 15 squared equals x squared. 8 squared is 64. 15 squared is 225. That equals x squared. Add these up, we get 289 equals x squared. And if we take the square root on the calculator, we will find that the square root of 289 is 17. So our missing side is 17. For our third example on the Pythagorean theorem, sides of 10 and x, hypotenuse of 14. We go and we plug it in. 10 squared plus x squared equals 14 squared. We'll need to get out our calculator. Find 100 plus x squared equals 196. Subtract that 100 over. We're left with x squared equals 96. Well, 96 isn't a perfect square, so when we take the square root of both sides, square root of x squared is x. Square root of 96, we have to factor. 96 will break down into 16 and 6. 16, remember, is 4 squared. 6 is 2 and 3, which isn't going to help us any. And so when we regroup this, we pull the square root of 16 out front, so the 4 comes out, and the 6 remains under the radical. Hence why we were doing reviews of radicals, simplification. Okay. The other thing we need to talk about is the different types of triangles we have. The first one being our 45, 45, 90 triangle. So special right triangles. So if we look at a 45, 45, 90 triangle, angles of 45, 45, and a right angle, we'll recall that this is has the same lengths on both sides. They become identical. And if we have x and x, our value for the hypotenuse, c squared, is x squared plus x squared. That is 2x squared. And if we go through and take the square root of both sides, square root of c squared is c. The square root of 2x squared. We can't take the square root of 2, it has to remain under the radical, but the square root of x squared is x. So our third side in a 45, 45, 90 triangle is x root 2. So if we look at a couple of examples, our first one, if we know the legs are 7 and 7, and of course this is a 45-degree angle and a 90-degree angle, what is x? Well, we know that whatever the side is, it's just that times root 2. So in this case, x is equal to 7 times the square root of 2. If we're given the hypotenuse, so we're given sides of x and a hypotenuse of 10, then remember that we can put this in to this equation, c equals x root 2 that we had up here. So we put 10 in for c. 10 equals x root 2. To solve for x, we're going to divide over the root 2, so it's going to become 10 over root 2 equals x. But we know we can't leave it that way. We have to rationalize the denominator. So we're going to multiply top and bottom by root 2. So we get 10 root 2 over root 2 times root 2 is 2 equals x. And when we simplify that, 10 divided by 2 is 5 root 2. So that's the 45, 45, 90 special triangle. The other special triangle we have is a 30, 60, 90 right triangle. And as you'll recall from geometry, in a 30, 60, 90 right triangle, the short leg of the triangle was x. The hypotenuse in that triangle actually becomes 2 times x, and the other leg is x root 3. So if we look at some examples of these triangles, find x, y. Number 1, we're given the short side of 5. Find x and y. Well, we know that the hypotenuse is twice the 5. So 5 times 2 is going to be 10. And we know that the longer side is the short side times root 3. So this becomes 5 root 3. If we're given a different part of the triangle, so for example, if we're given that the long side, or the hypotenuse, sorry, is 18, then there's a couple of things we know. We know that's twice as big as x. So if that's 18, x has to be half of that, which is 9. And once we get that value, finding y is simply the short side times the root of 3. It's a little harder when we have the hypotenuse given, or sorry, the long side given. So let's look at that. We're given the long side. So the long side's going to be a 7. We'll make the hypotenuse y. Our short side, we always make x if we don't have it. So we know that x times root 3 is going to be 7. So that means that x divided by root 3 or I'm sorry, right, x divided by root 3. Oh, I screwed that. Ha ha, and I'm not going to stop the recording. Ha ha ha. You're just going to have to deal with me. So, we know that if we take 7 and we divide it by root 3, that will give us x, because this is x times root 3. So to go backwards to x, we have to divide by root 3. So To rationalize that, we're going to multiply by root 3 over root 3. And we get 7 root 3 over 3 is equal to x. Now that we have that, y, of course, is 2 times that. So we get 2 times 7 is 14 root 3 over 3, and it doesn't reduce. Okay? That is the end of review number 2.